Finxter, this is Anqi. Today I'm going to guide you through my article about np.argsort function on Finxter.com. So in Python, this function returns the indices that will sort an array in ascending order. And in this video, I will first introduce its syntax and arguments to you, and after that, you will learn some basic example of this function. And after that, we will head over to 3 top questions regarding this function, including how to return the indices that will sort an array in descending order, and how to use its axis and order arguments respectively. And in the end, I would, of course, summarize this tutorial for you. And without further ado, let's jump into its syntax and arguments. So as you can see, I've shown a syntax and argument table on the same page so that you can have a better intuition of what is syntax and arguments really are. And so first, let's take a look at its syntax. So to use this function, you have to import NumPy library first, and then you can call this function using the dot operator, and along with argsort its name, of course, and this parameter list you have to pass in this function. And so since we have just talked about the parameters we need to pass to this function, let's take a look at its argument table right now. So first, you have to pass an array to sort to this function. And after that, you can have 3 optional parameters. You can choose to adjust or just leave it as optional, right? In your daily usage of this function, I think you will most likely to use axis and order arguments respectively. So in this tutorial, I will just introduce this axis and order arguments later in this tutorial. So that's our first part of this tutorial, to have a first impression of its syntax and arguments. And after that, we will head over to a basic example of this function. So our basic example is an one-dimensional array. So let's take a look at its code right now. So first, as I just mentioned, you have to import NumPy library first, and we give it an alias called np as convention. So, and next we initialize a one-dimensional array using np.array function, and we pass this one-dimensional array to a variable called oneDime. And then we call this function np.argsort, and we pass the array to sort to this function, which is the one-dimensional array we just initialized. And here I write a comment says axis default is -1, which is the last axis. Since we are only talking about one-dimensional array here, so it only has one and the only one axis. So this comment just you can pay attention to it, but it doesn't really matter in this function, in this case right now. And after run this function, we will have a sorted index that will sort this input array in ascending order. And we store the sorted index to the sort index variable. And after running this function, we would use 3 print statement to print out first the unsorted array and the sorted array index, which is the sort index, right? And then last, we would also print out the sorted array using a technique, just indexing, right? Just to use the unsorted array, and we index this unsorted array, use the sorted array index, and we would get the sorted array here. So that's basically what this code is all about. And after running this code in our terminal, we will get this output here. So as you can see, the unsorted array is what we initialize here, right? They are the same. And after running this function, we will get a sorted array index. So here, you can check, but I think a better way to check whether the function actually sort the array is to actually print out the sorted array using the indexing technique. And as you can see, the output is actually sorted. So that's it. That's it. This is a basic example of how to use np.argsort function. So after seeing this basic example, let's take a look at its three top questions: descending, axis, and order, respectively. First, we will take a look at how to actually return axis that would sort the input array in descending order, because as we see in its argument table, we didn't see an argument that's specified to control whether it's descending or ascending, right? So how can we actually do this descending order stuff? I will give you a moment to think about it. Okay, so let's jump to the answer. So actually you can use the -1 reverse trick. It's the same trick that you would probably have used in string in Python. So a quick recap is that if you have a string like hello, hello is too long, say hi. Okay, so you have a string hi here, and we assign this string to a variable called as, and if we use as colon -1 square bracket, and what we get for this operation is actually a reversed string, right? hi, we just reverse the input string. So it's the same idea when you want to, just to use the np.argsort to return an index that would sort the input array in descending order. So let's take a closer look at how this code actually does using this -1 reverse trick. So first, we import numpy library as np, and we initialize a one-dimensional array using numpy.array, and we assign this one-dimensional array to a variable called oneDime, and we again call this function numpy.argsort, and we pass the array to sort to this function. And after running this function here, we would actually get an index that would sort the input array in ascending order. But after this function call, we use the -1 reverse trick. So the ascending order is actually reversed to descending order using this trick here. So again, we assign this sorted index to sort index variable, and we print out the unsorted array, sorted array index, sorted array, the same as in our basic example. So let's take a look at its output. So after run this Python file, we will get the output here. So the unsorted array is the same as we initialize right here. It's just for presentation, so I intentionally to set this input array to be, just in ascending order, sorted in ascending order by itself. So initially it's sorted in ascending order, but after running this function and use the -1 reverse trick, we got the sorted array index, and of course we use the indexing trick here so that we can get the sorted array. Then we get the array sorted in descending order eventually. So it means that the reverse trick is applicable in this special application here. So that's our first top question regarding this function. Next, let's take a look at how to use the axis argument. So just to jog your memory, I showed the argument table for this function again, and this time our focus is the axis argument here. So let's take a closer look at its description. So this argument means axis along which to sort. Axis along which to sort. Okay. this is pretty clear. And the default is -1, which means the last axis. And as you can see here, it accepts integer or none. So you could set integers like -1, 1, 0, but you can also set it to be none. So, and if you set it to be none, the flattened array is used. The flattened array is a concept like if you have a two-dimensional array, right? If you have a two-dimensional array, you can think of it as a matrix, right? You can think of it as a matrix with, like row 1, row 2, row 3, and blah blah blah, like a matrix. And the flattened array here, the flattened array used here is actually, just turn this one-dimensional array into a turn this two-dimensional array into a one-dimensional array. And it does in this way, like, for example, if this row 1, row 2, row 3, then it will just, after the row 1 here stays the same, and we will pass the row 2 here, just right after the last element of the row 1, we would follow the first element in the row 2, and row 3 is here, and so on and so forth. So in this way, the flattened array is turning a two-dimensional array or higher dimensional array to a one-dimensional array. It's like a flattened, like a box. You just push it to, a thinner one. And this is how I comprehend this concept, flattened array here. It's more intuitive, but it's basically what I just explained here, that it would turning a two-dimensional array or a higher dimensional array into a one-dimensional array. And you can also refer to NumPy and the array.flatten function to learn better about what a flattened array actually means. So that's a basic introduction of this axis argument. And after this, we will take a look at some code example of this argument. So the first code example is that what will happen if we set the axis to be 0. So let's take a look at the code itself first. So we import NumPy as np, and we initialize a two-dimensional array, also using np.array function, and we assign this two-dimensional array to a two-dim variable, and we call this np.argsort function. We pass the array to sort to this function, and we set axis to be 0 in this case. And again, we pass the sorted index to the sort index variable, and we print out unsorted array, sorted array index, sorted array after running this function here. So let's take a closer look at what this output would be like here. So the unsorted array is the same as what we initialize here, and the sorted array index is hard to map this index with this array. So I also print out the sorted array here. But a noticeable difference between this example and previous examples is that here we use NumPy take along axis function to map back the sorted array using the sorted array index. The reason why we choose to use this function is that you cannot really just use the two-dim sort index like we did in a one-dimensional array, right? This does not work in a two-dimensional or higher dimensional array. You have to use NumPy take along axis function to map back from array index to array. Of course, you can use this function under one-dimensional array scenario, but the reason why I choose to use the indexing technique previously is that it's more acceptable, I think, for newcomer to this function. Anyway, so here we use NumPy take along axis here. We pass the array to sort and the sorted index, and then we set the axis to be 0. This is the same setting as here. And then after running this function, we will have a sorted array. So let's take a look at the sorted array and unsorted array, and to see if this function np.argsort actually did what it actually should be done. So the unsorted array is one. So before we look at the comparison between the unsorted array and sorted array, I have to mention that axis equals to 0 actually under the scenario of two-dimensional array means row-like. So for example, if here is row 1, row 2, row 3 is a two-dimensional array. The row-like means actually we are doing sorting in the row-like order. So in this scenario, the unsorted array, let's take a look at its first column, which is 1 and 3 here. And since 1 is less than 3, then we will leave it as it is in a sort, because this function is going to sort the array in ascending order, so we will leave as it is. And for the second column, it says as it is as well. And for the last column, it says 3 and 1. Since we have to sort this array in ascending order, so we will put the 1 first and the 3 after the 1 here. As you can see, the index is reversed here as well. It should be 0 and 1, but since the 3 is larger than 1 here, so the return index is 1 and 0 respectively. So that's the first code example for the axis argument. And in this code example, we set axis to be 0, and axis to be 0 means row-like sorting order. And our next code example for this axis array, this axis argument, is that we set this axis argument to be 1. So let's take a look at the code right now. So first we import numpy as np, and we initialize a two-dimensional array using numpy.array function, and we assign this array to a two-dim variable, and we call this function np.argsort, and we pass the array to sort, and we set axis to be 1 here, and after that we assign the sorted index to the sort index variable. And like usual, we print out the unsorted array, sorted array index, sorted array, and for our last sorted array, we again use numpy.takealong axis here. So after running this function, after running the code here, we get the output here. So again, this unsorted array is the same as what we initialized here. And for the sorted array, we will have a sorted array in a column-like sorting order. Why is that column-like? Because we set axis to be 1, and it's the same idea as I just explained for axis to be 0. It's just for a two-dimensional array. You can think of it as column 1, column 2, column 3, and when it does comparison for axis to be 1 case, it's actually done in a column-like order. So in this order for a two-dimensional array. So for this first row, column-like, let's take a look at the first row. So in a column-like order, it's already being sorted in ascending order. But for the second row, when we look at the second row in a column-like way, it's not sorted in ascending order. In fact, it's sorted in descending order for the unsorted array. So after running this function, numpy.argsort, it will sort the second row in ascending order in this column-like order. So that's our second example for axis to be 1. So our last example for this access argument is that what if we set this access to be none, which is another option for us to pass to this argument except for integers. So again, let's take a look at the code first. So we import numpy as np, we initialize a two-dimensional array, and we pass this two-dimensional array to a variable called toDime, and we call the function np.argsort. We pass the array to sort, and we set the access to be num here, and we pass the sorted index to the sort index variable. And again, we print out the unsorted array, sorted array index, sorted array, and we use numpy.takeAlongAxis function again to map back from the array index to the sorted array. So after running this file, we will have the output here. The difference, I'm afraid that you must have noticed the difference between the sorted array here and the previous two examples about access to be 0 or 1 is that, as I mentioned before, if you set access to be num, a flattened array concept will be used. So the flattened array concept is that turning two-dimensional array to one-dimensional array under this scenario. So the output sorted array will actually be a one-dimensional array for this access to be num case. So let's take a look at whether it has been sorted in ascending order. And for the unsorted array, it goes like the first row is 1, 2, 3, and the second row is 3, 2, 1. And if we compress this two-dimensional array, unsorted two-dimensional array into one-dimensional array, it should be like, the first row is 1, 2, 3, and the second row is 3, 2, 1. So initially, the two-dimensional array is turning into a one-dimensional array in this way. And after running this numpy.argsort, it actually will sort it into this way, sorted in ascending order 1, 1, 2, 2, 3, 3. So that's basically what this function actually does under the hood when we set the access to be num. So that's our last example for this access argument. I hope you now understand how to use this access argument to manipulate with access. So our next topic is the order argument for this numpy.argsort function. So although I said that you will probably only need to deploy the A, which is the array to sort, and access argument we just talked about, I think the order argument is probably still very confusing to you. So I will give you an example to help you understand what it actually means and what we can do with it. So in the official documentation here, the order argument goes like when A is an array with fields defined. Fields defined is a keyword, okay? And this argument specifies which fields to compare first, second, etc. A single field can be specified as a string, and not all fields need to be specified, but unspecified fields will still be used in the order in which they come up in the D type to break types. It seems like a lot to you at first, but I will break it down for you in the code example coming next. So I summarize what this argument actually does here. So this argument actually just specifies the order in which to compare field. So let's take a look at the code example for this argument. Here I list out a one-dimensional array example for this order argument. First, we take a look at the code right now. So we import numpy as np, and we initialize a one-dimensional array using numpy.array as usual, but this time we would change the D type here. We would assign a D type goes like with two fields. the field 1 is X, and the field 2 is Y. So you can think of it as 4 points here. I just initialize 4 points in a two-dimensional plane. They have axis coordinate and y-axis coordinate. You can think of it as it is, so that you can maybe have a better intuition of this example for older argument. So after that, we call np.argsort, and we pass the array to sort here to this function. But I didn't use order here because, as I just mentioned, unspecified orders will still be used in the order in which they come up in the D type. So this line actually does the same thing as this line here. You can set the order to be X and Y here, but it doesn't have to, because the unspecified field will still be used in the order in which they come up in the D type, since X come up in the D type first, then Y. So it's the same idea if you don't pass anything to the order here. So anyway, we print out the unsorted array for this order X is before Y, and we print out the sorted array index and sorted array respectively. And we print out a separation sign here. It's just my preference to print out a separation here so that you can have a clear view of the output of this Python file. So that's our first sorting order case. And our second sorting order case is that we can also try to compare the Y field before the X field. How can we do that? The rest is the same, only we set the order to be Y before X's. And that's our second order case here. So we also print out the unsorted array, sorted array index, and sorted array for our second order case here. After running this file, we will get the output here. So the above output is the output for the order that what X field is compared before the Y field, and the output here is the output for that Y field is compared before the X field. So let's take a look at the first part of the output first. So if we compare the X field before Y field, and if we compare the X field before the Y field, then for the unsorted array, what would be the first element? What would be the smallest element, or I should say, in the ascending order? It should be 1, 1, right? Because 1 is the minus X field, and for the column 1 is also the minus Y field. So 1, 1 should be the first in the output. And what's next? Next is also should be, since we are considering X field first, so we will take a look at X field, and we find that, okay, this X field is 1 and other X field is 2, so we will put this 1, 2 here. And after these two elements, what would be the next? Since the rest two elements here, 2, 2 and 2, 1, they have the same X field, so we will take a look at is there are Y fields respectively. So for 2, 2, the Y field is 2, and for 2, 1, the Y field is 1. So apparently we will put the 2, 1 here right after 1, 2, and our biggest element in this scenario should be 2, 2. And so that's our sorted mechanism behind for the order. Is like we compare X first, and then Y first, and then Y field. And for our second part of this output, we will take a look at the sorted mechanism when we said to compare Y field first and then X field next. So for this scenario, since we're comparing Y field first, so we will take a look at their Y fields first. So the Y field is 2, 1, 2, 1. So the minimum Y field is 1. And since we have two elements that have the one Y field, we will take a look at their X field. Their X field are 2 and 1. Since 1 is smaller than 2, so we will pass 1, 1 as the smallest element in the sorted array. And after that, we will pass the 2, 1 element in the sorted array. Since in the rest elements, the 2, 1 have the smallest Y field. And for the rest two elements, 1, 1, 2, and 2, 2 here, they have the same Y field. So we will take a look at their X field. Since 1, 2's Y field is smaller than 2, 2's Y field, X field, so we will put 1, 2 next to 2, 1, and we would put 2, 2 in the end. So that's basically what this order argument actually means and what we can possibly do use this argument. So that's it for our np.argsort article. We learned about its syntax, arguments, and basic examples. We also worked on the top 3 questions about this np.argsort function, ranging from np.argsort descending. We used the, I hope you still remember, -1 reverse trick, and np.argsort two-dimensional array / axis arguments, and np.argsort order argument. So, and actually, Python provides quite a lot sorting related functions, aside from this np.argsort function we just talked about. So I list out some resources that you might find interesting. For example, if you want to have more flexible with ties situation, check out the spicy.status rank data function. And if you want to indirectly sort an array with multiple keys, check out the numpy.legsort function. And if you want to directly sort an array instead of return indexes that would sort an array in ascending order, like the numpy.argsort function, you can check out numpy.sort and numpy.ndarray.sort function. Yeah, so last but not least, if you like this video, please hit the like button, and hope you enjoy all this, and happy coding. Until next time, bye.